Jai Hind everyone. Today we are going to talk about the data warehousing, data mining, the final year KOE 093 open elective subject, OLAP. OLAP basically means the online analytical processing tool, which is going to analyze the data on the real-time basis. For example, in general, if we are having a database, that database is already stored. We can run different queries on it. But if we are talking about the real-time data which is coming to us and which is going to be used or displayed somewhere, so for that what we need to do, we need to basically have something which can process the online data available to us. So for that purpose, we are going to use the certain techniques known as online analytical processing. So if we are generally talking about the warehouse and data mining, these are some of the important topics which we have already discussed or which we are going to discuss. The warehouse, the multi-data, multi-model dimensional data, the warehouse architecture, implementation, and the data cube technology, and finally how this data warehousing started and we moved towards data mining. So basically the warehouse, as we all know, it is a decision support system or the database that is maintained separately from the organization's operational database, support the information processing for providing a solid platform of consolidated historical data for analysis. A data warehouse is a subject-oriented, integrated, time-variant and non-volatile collection of data in support of management's decision-making process. Or we can say it is a constructing and using the data warehouses in different ways. So as we have talked about, it is subject-oriented, integrated, time-variant and non-volatile. We are going to discuss these four features basically. After that, we will talk about how it is going to contribute for OLAP. So here the first characteristic, that is subject-oriented, is available. Organized around major subjects such as the customer, product, sales, etc. Focusing on the modeling and analysis of data for decision markers, not on daily operations or transaction processing. Provide a simple and conscious view around particular subject issues by excluding data that are not useful in the decision support process. Next important characteristic, second one, is integrated. It is constructed by integrating the multiple heterogeneous data sources, relational databases, flat files, online transaction records. Data cleaning, data integration techniques are applied, ensure the consistency in naming the conventions and encoding the structures, attribute measures, etc. along different data sources. For example, the hotel price, concurrency, text, the breakfast covered, etc. When data is moved to the warehouse, it is converted. For the time variant purpose, it is somehow, it is in time variant. By time, obviously, the data warehouse provides the information from a historical perspective as well. For example, from the past 5 to 10 years also we have some data. Every key structure in the data warehouse contains an element of time, explicitly or implicitly, but the key of operational data may or may not contain the time element. So these are the time variant things. Finally, the non-volatile, a physically separate store of data transformed from the operational environment. Operational update of data does not occur in the data warehouse environment, does not require transaction processing, recovery, and concurrency control mechanisms, requires only two operations in data accessing, that is initial loading of data and access of data. So basically what we are going to talk about is the data warehouse is subject oriented. The number one is subject oriented. It says that it is going to be focused or some subject centric. It is subject centric. It is going to focus on some of the subjects, definitely. Means if we are talking about the warehouse of an organization, then obviously it is concentric to that particular organization. If we are talking about an institute or college, basically the data warehouse will consist of related to all the students, their subjects, their marks, their attendance, whatsoever it is. Like this, different departments. If we are talking about the account section, then it has everything related to the accounts or finances. If we are talking about the HR department, then it has everything related to human resources. So basically what it means that it is always subject oriented, means for a particular subject the warehouse is created and it has each and every information related to that subject. So we can say it is subject centric as well. Second one is integrated. Integrated means it is connected to each other. For example, there are different departments we have, and all those departments constraints to a single organization. So obviously they are interconnected with each other as well as they are directly connected to that organization. So like this we can say how the integration of different departments contributes to the warehouse. Next one is time variant. Obviously by time it is required. Maybe we need a data which is we used 2 years back or 2 months back or a few days back, or maybe we need some data to predict something. So for that we will take out all the historical data. That historical data may be of 5 years, 10 years, 15 years before we have used or stored. So for that we can see it is very important for us that time variant. Because of that the warehouse plays a very important role. When we have a stored information or data, we can use it whenever we require it for future reference. Non-volatile, obviously it will updation of data does not occur in this. As in database we keep on updating the data depending upon the requirements, but here we cannot perform any updation. It will be as it is, or we can take that data and use it somewhere, but we are not going to update that data. Here how the data warehouse versus the heterogeneous DBMS works. So traditional heterogeneous database integration, basically it has built wrappers, mediators on the top of the heterogeneous databases. Query driven approach is there. When a query is posed to a client side, a meta dictionary is used to translate the query into the queries appropriate for individual heterogeneous sites involved, and the results are integrated into a global answer set. Complex information filtering complete for resources, data warehouse, the update driven high frequency. Information from heterogeneous sources is integrated in advance and stored in warehouses for direct query and analysis. Here it is how we are going to differentiate between the operational database management system with the data warehouse. So OLTP, that is the online transaction processing, which says that the major task of the traditional relational database it is somehow you can say the OLTP and OLAP is something analytical. The historical data is going to be used for analysis in OLAP. In this online transaction processing, the online transactions of bank accounts are considered. It is real time and it is performed on historical data. So this is the main difference between these two, OLTP and OLAP. So basically let's see the distinct features of OLTP and OLAP. User and system orientation is the data content is current, detailed versus historical and consolidated. Obviously database design is ER plus application versus star and subject. View is current and local and evolutionary and integrated. Access patterns are update versus read only, but complex queries are there. So on the basis of these characteristics, these features, we can differentiate between the OLAP and OLTP. In OLTP, the user can be a clerk or IT professional. And in OLAP, it is a knowledgeable worker. Obviously, transactions are taking place. If, for example, a bank account transaction is taking place, in that case, you need a clerk or IT professional. But for some analysis, what you need a knowledgeable person who has knowledge, who will predict something, who will analyze something, and finally, it will give the result or conclusion. That is knowledge worker. Next is function. Function is it's day-to-day operations, and it is decision support. Database design is application oriented. Here it is subject oriented. Data is current, up-to-date, detailed, flat, relational, isolated it is. And here it is historical, summarized, multidimensional, integrated, and it is repetitive, it is ad hoc. Access is read and write, indexed hash or primary key, it is lots of scans are there. Unit of work is short, simple transaction, here it is complex query. Record access, it is 10, for example, and it is millions of things are there. If you are talking about the user, it may be thousands or hundreds. Database size is 100 MB to GB, here GB to terabyte. The matrix is transaction throughput, here it is query throughput and response. So like this, we can see the online transaction processing and online analytical processing are different on the basis of these particular features and characteristics. What separates data warehouse? The high frequency performance for both systems, that is DBMS, it is turned from OLTP, access method, indexing, concurrency control, recovery, and the warehouse tuned for OLAP, that is complex OLAP queries, multidimensional view, consolidation, etc. Different functions and different data is there, that is missing data is there, data consolidation will be there, and data quality will be there. From tables and spreadsheets to the data cubes. Yes, this plays a very important role. A data warehouse is based on a multidimensional data model which views data in the form of a data cube. What this data cube basically means? Let's have a look. It is a cube in which we have 3 dimensions. 1, 2, and 3. It has 3 dimensions. Now data can be stored over here in these boxes, in these cubes. For example, here we have in which year how much quantity is produced and which particular item it is. For which particular item, how much quantity is produced in which year. So like this, we can say it has multi-dimensional data model. A data cube such as sales allows the data to be modeled and viewed in multiple dimensions. Dimension tables such as item or time. Fact table contains measures and key to each of the related dimension tables. Cube, a lattice of cuboids. Basically, what it shows that which particular type of cuboid it is, 0 dimensional, 1 dimensional, 2 dimensional, 3 dimensional, and 4 dimensional, that is base. So like this, somehow it is connected. Time, item, location, and supplier are there. They are sub-connected with the time and item, time and location. Here time and supplier, then item and location and supplier. So like this, it will keep on going like this towards the downward direction. Conceptual modeling of data warehousing. As we have already discussed these 3 types in our previous lecture, let us talk about in brief in the form of more conceptual way in terms of the OLTP and OLAP. So basically in star schema, you already know it is a star kind of a thing. In snowflake schema, it is somewhat like this. And And in this fact constellation, it is much more complex in upward direction and downward direction. So let's have an example. Here we have a star schema in which the sales fact table is there. These are certain keys: time key, item key, branch key, location, unit, dollar, and average. Time, branch, measures, location, item. All these tables are connected and it is a star kind of a thing. You can see it is a star kind of a thing, which I have already told you in the previous one. Here, star. Slow flex, you can see how it is connected. It is connected to more than that also. It is sub-connected to this one as well. It is also connected to this one. Here they are further connected to the some more. So it is somewhat like this. Somewhat this kind of characteristic it has. Means the main table is there, it is connected to other one, and further those tables are connected to more different parts. In this fact constellation, any other table is connected to any table wherever it is needed. It is connected to anyone and anywhere wherever it is needed. So it is an important query, a data mining query language, that is DMQL, in which you can say cube definition, dimension definition, and spatial cases are there. I'm not going to discuss all these in details because as we have already talked about it in our previous practical classes. So as you can see, all these things are there. Basically, we are going to talk about the measures and three categories over there. This is distributive, algebraic, and holistic. In distributed, if the result derived by applying the function to n aggregate values is the same as that derived by applying the function on all the data without partitioning. For example, the count function, sum function, minimum, max function, etc. Algebraic, if it can be computed by an algebraic function with m arguments, each of which is obtained by applying a distributive aggregate function. Holistic, if there is so constant bound on the storage size needed to describe a sub-aggregate. So you can say in algebraic it is average, mean, standard deviation, and in holistic it is median, mode, and range. So this is the dimension regarding the location. All are there. If we are going to subdivide it in the terms of region, it is Europe, North America, for example. If we will talk about country, then in Europe we have the Germany, Spain. In North America we have Canada, Mexico. Further, if we are talking about the city, then we are in Germany we are talking about the Frankfurt, or in Canada we are talking about Vancouver or Toronto. Like this, it is a complete thing all. And by that, by going down to that particular tree, we are going to subdivide in the terms of region, country, city, and offices, etc. So this is multidimensional data. You can see here the months are there, product is there, and region is there. In which month, which product is produced, in which year, and how much. You can say dimensions. Product, location, time, hierarchical summarization parts, that is industry, category, product, region, country, city, and office, year, quarter, monthly, week, day, etc. So these are subdivisions for it. But the main purpose is whatever cube we have created, if we are talking about a three-dimensional cube, obviously, if it is a 3D cube, it will produce three things at the same time. In which year, in which month the product is produced, in which year. If we want, we can make it more dimensional by using this multidimensional model. That how much amount of that particular item is used. Maybe this is one of the more important dimension if we want to add, but then it will become more than this. Right now it is 3-dimensional, then it will become more dimensional. It is a sample data cube. You can see that how countries are there, dates are there, and products are there. And each and every cube is defined over here, that how it consists of each and every individual information. You can see here. This is cuboids corresponding to the cube. All right. This is browsing a data cube. You can see that how these countries are there, their locations and products are there, and how their values are going to be shown with these small cubes. And when all these small cubes come together and we combine them, we join them, then it will look like somewhat like this, as we have already seen our previous slides. Now, typical OLAP operations are there. That is, first one is roll up or drill up, that is summarize data by climbing up the hierarchy or by dimension reduction. Drill down or roll down. Reverse of, that is roll up reverse, from higher level summary to lower level summary or detailed data, or introducing the new dimensions. Next is slice and dice, that is project and select. Pivot, that is rotate. Reorient the cube, visualization 3D to series of 2D planes. Other operations are drill across, drill through, that is drill across means the involving across more than one fact table, and drill through means through the bottom level of the cube to its backend relational tables using the SQL. So it is a star net query model, that how the product time, customer order and promotion are connected, and in these 4 regions we are having sublines of the customer, shipping method, the location and organization. So you can see there are certain points given and how those points are connected. That is also creating a star net. Design of data warehouse as a business analysis framework. In regard of this, we have 4 views for designing the data warehouse, that is top-down view, data source view, data warehouse view, and business query view. Here, the top-down, bottom-up approaches are combined together. You can see top-down, bottom-up is there. In software term, there is waterfall, spiral is there. In this waterfall, it is somewhat like this, as waterfall grooves. In spiral, it is somewhat like this. So these are these 2. Typical data warehouse design processes are there. We need to choose a business process, then we need to choose an atomic level of data, that is grain, or dimensions we need to choose, and measure we need to choose. Multi-tiered architecture. In this multi-tiered architecture, we have basically in center we have the data warehouse. It is somehow connected to some other things. What are those some other things? Very important one is the OLAP engine. OLAP engine is there. This consists of server, OLAP server. Then next to it is the front end tool, which has the analysis query reports, that is data mining. And other side we are having the data sources, those sources from which we are collecting the data, we are getting the data. That particular point is known as the operational database. 3 data warehouse models, obviously the enterprise, the data mart, and the virtual warehouse. It plays a very important role in terms of information when we are talking about information. Number first is the enterprise warehouse, which collects all the information about the subject spanning the entire organization. Data mart is a subset of corporate wide data that is of value to a specific group of users. Its scope is confined to specific selected groups such as marketing data mart. Next is independent directly from the data warehouse or data mart. Virtual warehouse, we have a set of views over operational databases and only some of the possible summary views may be materialized. It is the recommended approach that how it defines a higher level of corporate data model in which the enterprises are there, data marts are there, which are distributed among, and multiple, you can say multi-tier data warehouses there, which is somehow connected to all these things. It is going towards here, it is going towards here, and it is going towards upward direction like this. So starting from a higher level corporate data model, it is going towards the multi-tier data warehouse. This is now the OLAP server architecture. It is relational OLAP, that is ROLAP. Next is multi-dimensional OLAP, that is MOLAP, and hybrid OLAP, that is HOLAP. These three are very important from exam point of view as well. That what do you mean by OLAP server architectures? Explain all of them in detail. So this ROLAP, MOLAP and HOLAP plays a very important role. So here we have first one, we will talk about the relational OLAP, that is use relational or extended relational DBMS to store and manage the warehouse data, and OLAP middleware to support missing pieces. Second point is includes the optimization of DBMS backend, implementation of aggregation, navigation, logic, and additional tools and services, greater scalability. In multidimensional, we have the array-based multidimensional store engines, the fast indexing to pre-computed summarized data. Hybrid is, that is completely a user flexibility and low-level relational and high-level array, like this. Again, the cube operation is there, how this cube has different items and different parameters and how they are connected. Again, for this, we have a particular kind of a query. Here we have some of the important diagrams just to understand the multi-way array aggregation for cube and computation. Means how we can traverse order to do the multi-way aggregation, that plays a very important role. So these are some of the important examples. Here it is, the indexing OLAP data and bitmap indexing. So like this, all these things comes under the category of OLAP. The main important thing is we need to understand the difference between OLAP and OLTP. So that's all for now. Thank you.